Welcome to the Chapter 10 Beginning Algebra Review. We will be reviewing the things from this chapter to prepare you for the project you're going to do, which is super fun. I'll give you the details on that later. But today, what I want to do is cover some things in Chapter 10 that you had to do on your own. I sent some resources last week, some great videos, some great explanations. Hopefully you found something that worked for you. You didn't have to do all of it. You just needed to find what worked for you. So hopefully you found some great things. If you didn't, I'm going to go over some things here. I'm going to hit the highlights. I have set up a Google Meet, so you can come talk to me on Monday, Wednesday, Friday from 1 to 2:30. I sent you the link on Remind. I sent you an email. So you can come ask me questions on that. I can work through problems for you, and we can get you all straightened out. Keep in mind, you're going to do the Chapter 10 review evens. That will be a quiz grade, okay? I'm asking that you use your integrity here. You do not use a parent, a sibling, a tutor, Google, Photomath, anything. You simply do the Chapter 10 review evens using your book. You may use the formula sheet I gave you and a calculator. There are a lot of formulas this chapter. I know that. Not expecting you to memorize all of them. However, the more problems you do and practice, you'll find the more those formulas stick in your head. Okay? So, I'm going to hit a few highlights here. Again, if you have questions, you can come see me in Google Meet. That'll be easier than a ton of emails. So, Chapter 10, Section 1 review was triangles. Okay, just remember there's 180 degrees in every triangle. So when you're figuring out the measurement of a missing angle, you're setting all of them added up equal to 180 degrees. All right, you classify triangles two ways, by their angles and by their sides. If it has a right angle, it is a right triangle. If all the angles are smaller than 90 degrees, it's an acute triangle. If one angle is more than 90 degrees, it's an obtuse triangle. So that's classifying them by their angles. You can classify them by their sides. If all sides are equal, it's an equilateral triangle. If two sides are the same, it's an isosceles triangle. If three sides are all different measurements, it is a scaling triangle. So remember, you can classify triangles two ways. So that's Section 10.1. Section 10.2 talks about whether it's a polygon or not. Hopefully you remember that class discussion we had. And you're looking for whether or not there are curved sides, open corners, anything like that. Okay? We talked about concave, convex. Hopefully that rings a bell. I'm going to jump to 10.3, areas of parallelograms and trapezoids. Okay, the important thing to remember here is what their bases look like. Okay, so I'm going to get a little shape here before we get too far. And just remind you, all right, that when you have parallelograms, trapezoids, the important thing is to look at those bases, okay? And the bases are the parallel sides. In this case, a rectangle, obviously, they're all parallel. In number 11, all right, it tells you there that the bottom side is 3 inches, okay? So that is your base there because the other parallel side is above it, it's 3. So for the formula for 11, area equals 1/2 base 1 plus base 2 times the height. And it tells you there, remember height is indicated by that perpendicular line, that right angle. All right, the height there is 2 inches, yeah. All right. Well, I'm going to write H. Well, I'm going to write H there first. Okay. And so I have 1/2, 3 plus 3, and the height is 2. Now, just remember that this always has to be done together. You can go ahead and divide that 2 by 2, which is 1. And then you get 3 plus 3. Hopefully all of you know that. All right. That's 6, and it's inches squared. Okay. So that's trapezoid parallelogram. Again, this is the work I'd like you to show. All right, I'm writing the formula, I'm plugging the numbers in, so I can follow what you're doing right and wrong. Okay, we're going to look at 10.4 just real quickly. 10.4 is the area and circumference of circles. The important thing there is to pay attention. If you're looking for the area, which is pi r squared, and they give you the diameter, you have to cut that in half to use the radius, okay? On your calculators, usually you can use 3.14. If they want you to use pi, and pi is not a key on your calculator, maybe it's above a number, you use the shift key and that number to get pi that's above it. I'm not going to go through all those because I think those are pretty familiar. Jump to 10.5 and 10.6. I'm going to put these together, surface area, prisms, and cylinders. Okay, again, this is where you have to pay attention to the bases, okay? Really important thing to know, this cursive L, and they do that because just a regular L would look like a 1, is the slant height. Well, what are we talking about, the slant height, okay? So, what you have to look at, whether you have, when you have pyramids or prisms, right, no matter how it looks in your book, the bases are the parallel sides, okay? Just because it's sitting like this in your book doesn't mean that this is the base. Not so. If you think about it, you can twist it and realize it has to be like this. Whatever the parallel sides are, okay? There'll be two of the same, right? Parallel sides. All right, this is not the base of this. These are, okay? So that's important for these formulas. The other thing that's very important is to recognize slant height. Okay, slant height is on the outside of this pyramid. All right, if I'm looking at it, when I have the inside, this is the regular height from that vertex up there to the base. This on this side, you can see it well with the, is the slant height, okay? So that's what those letters mean in those formulas. Let's look at number 15. All right, we have a rectangular prism there. Again, it's important to look at the base, all right? But 15, we have a rectangular prism. Okay, so again, with all of them, the surface area is 2 times the base, because we have 2 of them, plus the perimeter of that, plus the height. Okay, the base is 7.5 by 3. Okay, so the base there, 7.5 times 3, plus the perimeter, we're talking about the perimeter around the base, 7.5 plus 7.5 is 15, plus 3 is 6, so that's 21. And the height there is 3. Okay, so if I multiply, I'm going to go ahead and grab my calculator here, because you can use them, all right? So I've got 7.5 times 3 times 2, and that is 45, plus 21 times 3 is 63. So my surface area for 15 ends up being 108, and that is inches squared. Okay, so again, pay attention to your base shapes and make sure you're finding the area. Remember that capital B means area of the base. It doesn't mean a length of a base as a triangle. Capital B refers to area of that shape. Okay, let's go ahead and do 19. All right, we've got a pyramid there. So, formula for surface area of that is base plus 1/2 perimeter times slant height. Okay, so we have the base of 19, which is a triangle. All right, so 7 times 7 for a triangle is length times width divided by 2. So the base there is 1/2 7 times 7. Okay, plus the perimeter of that base is 7 on each side, and it is a square, so we have 28. That's the perimeter there. And the slant height is 6. All right, so for that, oh, I made it like it's a triangle. It is not, it's a rectangle. So, all that works. 49, all right, plus we have, and I would do the 6 divided by 2, which is 3 times 28. And when I add all that together for 19, I get 133 feet squared. Again, pay attention. My mistake here, I was looking at another shape and I put it like it was a triangle. It is not a triangle. It is a square base. So my area there is 7 times 7. All right? There you go. Surface area, prisms, cylinders, pyramids, cones. Probably a lot of you, the cylinders with the radius and stuff, that's more straightforward maybe. You're just applying that formula. All right? We're going to lastly look at the volume. Okay, volume of prisms, cylinders, pyramids, and cones. Let's go ahead and just jump to number 3. 23. You can tell it's the end of the day here. 23. All right, and the formula here for volume is the area of the base times the height. Okay, so here's that shape I was talking about. All right, you've got it like this. You've got it, you know, it kind of looks like it's at a different angle, you know, in your book, more at a wonky angle, but you have to recognize what your base is, and that's the triangle for 23. All right, so you have the area of the base. So 7 times 8. Okay, but you have half of that, right? Because it's a triangle. All right, so area of the base, 1/2, base times height, 1/2, 8 times 7, times the height. Again, if you're looking at it, here's your prism, stand it up so that you can think about it, base and base. The height is that side, okay? So you're multiplying that by 12. Okay, I like to do 12 divided by 2, so I have 6 times 7 times 8. My volume there for 23 is 336 meters squared. Meters cubed. We're doing volume, 3-dimensional, okay? So your volume there needs the cubic label, meters cubed, inches cubed, whatever it might be. All right, so hopefully that review has helped you. Again, if you have any questions, you can come see me on Google Meet, Monday, Wednesday, Friday. Turn your things into Google Classroom, and good luck.